All right, guys, I'm going to make a couple of videos to help you, especially if you weren't in the synchronous class, or maybe you just forgot on how to do these problems. But this is going to be how to fill out both of the assignments. The one that you see right now is the class winch data table. You need to fill out this data table completely. Okay, all these empty spaces here completely. I'm going to review how we did the 5 pound and the 10 pound, but you need to do all the rest of these here as well as the 0. And then you need to make a graph of the information down here. Okay, so that's how you complete, what you'll need to do for that. Okay, so and you'll also need to make sure that you complete sorry about this. The Winch Lab as well. So I went through all this introductory information. You need to have in your lab, in your notebook, everything that's in yellow written up in your notebook, and you will turn that in. And as well, you need to have all this data filled out, and that's what I'm going to review over with you right now. So the first part here says to measure and record both weights and attach to the winch, record the number of decimals shown. So we have a 5 pound weight, and we are going to convert that 5 pounds to kilograms first and then to newtons. And we know that there are 2.2 pounds per every 1 kilogram, and pounds cancel out, so we have 5 divided by 2.2. You can do that on your calculator and you will get 2.273 kilograms. But we need to find out the force, which takes in consideration the force of gravity pulling on this object. And so we need to convert this to newtons. So we go 2.273 kilograms, and our conversion factor for this is that there are 9.8 newtons for every 1 kilogram. This is the same conversion that we did when you guys ran up the stairs and you had to convert your weight from pounds to newtons. So we have 2.273 times 9.8 gives us 22.275 newtons. And this is just, what you guys are going to have to do on your calculator. Open up Desmos and do this multiplication to get this, okay, for each one of the weights that you're using. 22.275. Let's see. So that was 22.275. And that answer goes right here. Lifting force. Oops, not right there, right here. 22.275. Okay, because we're doing the 5 pounds right now. All right. This is for 10 pounds, and maybe we'll make another video for the 10-pound mass, but I'm going to do them all for the 5-pound mass first. In every one of these, you only have to do this one time. We're going to convert 5 centimeters. It needs to be in meters. So to convert 5 centimeters to meters, there are 100 centimeters for every 1 meter. Centimeters cancels out, so we have 5 times 1 is 5, divided by 100 gives us 0.05 meters. So there are 0.05 meters in the winch lifting activity that we did. So the first one, and we're doing this for the 5-pound weight, for 5 pounds, we converted that to newtons, was 22.275. We already did that conversion up above. And then at the 5-pound video, what you're going to need to be doing is for each one of these weights, you're going to be using this information right here. Okay, this is for the 5-pound weight. The time it took to lift the 5-pound mass was 5.8 seconds. It has 7.5 volts for each one and 0.24 amps. Okay, so for this data right here, I'm just taking this right off of that chart that we were just looking at. 7.5 volts, 0.24 amps, and the time was 5.8 seconds. I want to just double check that. Yes, 5.8 seconds. All right, and again, I'm going to skip the information for the 10-pound weight because that's a different one, and maybe I'll make another video for that. We're going to calculate the amount of work that was done. We're going to use this equation right here. And for weight number one, weight number one is for the 5 pounds. Okay, so this one here is for the 5 pounds, and we can do it again down here for the 10 pounds. But work equals force times distance. The force that we calculated up above, 22.275 newtons, times the distance we calculated up above, 0.05 meters. If you multiply 22.275 times 0.05, we get 1.114. Newtons times meters is the unit of joules. Okay, 1.114. Work, 1.114. And I don't have to put the units, joules, because we've got units all up on the top here for everything. So you can just put numbers. Okay. Next, we're going to calculate the power out. Remember this lab, what we're doing is we are using a power source to turn a motor, which lifts a weight, and that is going to give us the amount of power that was used is the power in, and the power out is work divided by time. So that's mechanical power. The amount of work we just calculated right here, 1.114 joules. Oops. 1.114 joules. And the time, we get the time again right off of this chart right here, and this is it right here. On the second column there, this column here is where we're getting information, is 5.8 seconds. So our time is 5.8 seconds. Joules per second is watts. 1.114 divided by 5.8 is 0.192. 192 watts. Okay, that's our power out, 0.192. Oops. Power in, here's our formula right there. Power in is current times voltage. And again, I get my current right off of that chart that we keep flipping back and forth to. Here's our current was 0.24 right here in the second row. 0.24 amps times 7.5 volts. 0.24 times 7.5 gives us 1.8, and again, that's watts, power in. And put that 1.8. Sorry, it's a little bit messy there. I'm trying to be neat. And then we can calculate our efficiency, because the whole idea is to calculate the efficiency of this winch in lifting these different weights. So the equation for efficiency is power out divided by power in times 100. Okay, we just calculated the power in, goes on the bottom, 1.8, and the power out right here is 0.192. 0.192. 0.192 divided by 1.8 gives us our efficiency. And oh, we forgot here, you have to multiply this times 100 equals 10.67%. And that's how you do these problems. Remember also at the end here, I'll tell you right now, you're going to have these questions to answer, but you need to do exactly what I just did here for the 5-pound mass. you're going to do the same thing for all of these other masses here. Okay, and for these different weights, n plus 0. And for that, you have all of these different, the voltages are all the same, 7.5, so that's not going to change. But the time that it takes to lift these different weights changed, and also the current changed. So that's going to change your numbers that you get for each one of these up here. Okay, as for these here as you're doing your calculations. But I think I'll go ahead and do another video for the 10-pound, so you'll have the two that we did in the synchronous class available for you. Write to me, email me if